Hello, everyone. Welcome to today's webinar. My name's Ashley Ward. We'll do some introductions very shortly, and I'm joined by Roi and Yonatan. But I am just your moderator for today. The two stars of the show are on screen just now. I will be switching my camera off. Thank goodness you don't need to look at me through the webinar. I might pop it on again every so often to put any questions to our two threat researchers. And on that note, you'll see there's a Q&A button just there. Please do use the Q&A, put questions in. I'll be monitoring those. I'll be keeping a track of how our timings are. So if you do ask a question, then we'll either come to it at the end or I'll interrupt our speakers to be able to ask that question. If we are pushed for time, we've got a live demo and we've got to pray to the demo gods that things go well as always, but I'm sure they will. If we are pushed for time, the questions are recorded and we'll be able to get back to you with those. Talking about getting back to you, the slides will also be available afterwards and there'll be an on-demand recording which will be sent out to all of you. So without further ado, let me bring up some slides. Alrighty, hopefully you'll see some slides there coming through and some very nice pictures. Roi, would you please introduce yourself?
Yes, hi to everyone. Pleasure to be here. My name is Roi Nisimi. I'm security researcher at Orca Security, and happy to share this information today with all of you.
And Yonatan, the second most important person here. No, equally important person here.
Yeah, hi guys, I'm Yonatan. I am a threat researcher here at Team Axon at Hunters. And yeah, love to be here and love to collaborate with my dear friend, Nisimi. Yep.
Perfect. Yes, and as I've mentioned earlier, my name's Ashley Ward. I'm a principal technical evangelist, which means I talk all the talk while the people here also do the actual work. And as I mentioned, thankfully, you won't be hearing from me that much. Roi and I are from Orca Security. Orca Security has been built from the ground up because we realized that, well, our founders realized that operating a cloud native environment and in public cloud environments allows us to do security in a completely new way and actually be a lot more effective at security than would otherwise be possible. This is thanks to our patented side scanning technology, which means that we can have complete coverage of all your different workloads across all of your different cloud service providers, and we can provide the actual context to those alerts. So no more alert fatigue, you actually know what to concentrate on. And we're joined, of course, with Yonatan. Yonatan, would you please describe Hunters for us?
Yes, so at Hunters, we're building what we call a SOC platform, if you like, the next generation SIEM. And what we basically do is to develop a product that have take all of your data and have out-of-the-box detection capabilities over the entire attack surface, on-premises, cloud, SaaS. And what we do afterwards is to running additional layer of automatic investigation, which help to prioritize the alerts and help the security teams that operate with it to know what they should focus on, what alert in what time. Very exciting stuff, getting a lot of innovation into the old SIEM world. And also part of a team named Team Axon at Hunters. As you can see, we also have a cool logo. But as part of the logo, we are Hunters threat hunting and research team. And we are researching new attack vectors and trying to hunt for advanced adversaries that sometimes the security products miss. And yeah, that's about Hunters and Team Axon pretty quickly.
Very, very cool. Yeah, and we'll certainly have some links at the end where people can learn a lot more about both companies. I mean, you know, Team Axon, you've got a cool name there. That's actually pretty good. But I mean, it's really great that you're both threat researchers and you're collaborating. But I mean, first off, you know, what's threat hunting then? You kind of brushed over it, but give us a bit more of an in-depth idea.
Yeah, so you know, threat hunting is a big word, but in my opinion, it's the art of thinking proactively about threats rather than reactively. So instead of just responding to alerts that coming from the security products, which should be done, it is another layer of assuming that there is an attacker inside the network and try to think on a hypothesis of what this attacker does. And with that, be able to catch adversaries that maybe bypass the known security alerts that products providing. Now, at Axon, we have, like, in general, there are a lot of approaches for threat hunting, but at Team Axon, we have a couple of interesting approaches. For example, one of them is detecting the unknown. So what we basically say is that adversaries using new techniques, new offensive techniques, and maybe vulnerabilities that no one know about, right? Because they discovered it, the attackers discovered it, and no one know about. So we're putting efforts into investigating new offensive techniques that no one know about. And after researching those offensive techniques, we can hunt for them and maybe found adversaries that using those techniques or maybe similar techniques in the environment. And this is, by the way, also the example of Delifriend that we'll speak today.
Awesome. No, that's okay. That's cool.
I'll just add to this one. This is brilliant, and this is actually what we can call the new age of defending, where we implement attackers' perspective to understand what can go wrong in our environments when attackers can compromise things inside the network. So just a side note, really good stuff.
No, that's really cool. And so a nice then a question for you would be, I mean, apart from I get the community, you're both in the same field, and it's really cool and interesting. But I mean, what brings Hunters and Orca Security together today? Where's the partnership coming from?
So first of all, me and Yonatan are great buddies, so that's why we're collaborating. But the second more important thing is we want to contribute to the industry. Essentially, Orca and Hunters are two products that work extremely well together. So what we want to do in this webinar and overall in our collaboration today and in the future is to create a map from end to end to what an attacker can do inside your environment and what you can do as a security team to stop them, to remediate the risk, and to do the best you can possibly can in order to mitigate attack vectors.
It's really, really cool. So the last thing, actually, I've got on the slide there, I'd put in, and everybody who's watching, this is the only slide I've done, so you can see the level of stuff that I'm doing. I'm really conscious about time because I really want to hear you both speaking. So I was going to ask for a high level about Delifriend, but I think we're going to dive into it. So I'm quite happy to just set the scene and say that there's something we're going to learn about that's to do with Google Workspace and GCP very quickly. I know that we integrated as an Orca security platform. We cover GCP mainly. I mean, what's the crossover? Is there something very quickly we can say to everyone who's watching?
So very quickly about Delifriend, I will do kind of a teaser because, again, I don't want to do spoilers for the webinar. It's basically a security flow that we discovered at Team Axon here at Hunters that allows to a GCP IAM user with low-level privileges to move literally to workspace and be able to potentially impersonate to all of the identities in the workspace. And here I will stop because I don't want to do spoilers. We will speak about it.
Well, that's awesome. Okay, well, then in which case, let me do two things. One is to move the slide deck forward, hand control to you, and then I'm going to switch off my camera, and I'm really, really looking forward to this. On you go.
Nice. Thanks, Ashley. Appreciate it. Yeah, so let's speak in a high level about what is Delifriend. We will delve into it during the presentation. I just want to give kind of a teaser and explain what we are trying to do here in this webinar. So what is Delifriend? Delifriend is basically a security flow in GCP and Google Workspace in a feature that named domain-wide delegation. We'll also speak about this feature as well. But it basically allows to connect between GCP resources and the identities in the workspace. And the technique, the Delifriend, basically allows to GCP IAM user to take over on the entire workspace domain and be able to impersonate to any user in the workspace domain. So we're putting our hands on a relevant GCP IAM resource can let us to compromise the entire workspace domain, all of the identities, all of the employees, simply all of them. As you can imagine, we reported it to Google. It also accepted by Google as part of the Bug Hunters program. We appreciate their support. And if you're curious about what is the current stage with it, it's currently under the evaluation of the Google product team. and they looking into mitigation and option to reduce the risk. But it basically means that it's still open, it's still active, and this is why we are doing this webinar. We want to speak about it, we want to show it from both perspective of the GCP, of the workspace, and help organizations to know how to deal with it. We also published a research paper regarding it 2 months ago when we published DailyFriend. So if you're curious to learn about the bits and the bytes, and understand how it really works, how we discovered it, feel free to check out the Hunters blog. Everything is there. Don't worry, you will learn a lot of things in this webinar, including the live demo, but just in case that you want to take it even step ahead and learn some more. So this is really high level about DailyFriend.
All right, I'll take it from here. Thanks, Yonatan. So this is the overall attack diagram that we will present via a demo. And Yonatan described DailyFriend just a slide ago. And this is the main thing we want to focus on this webinar, the DailyFriend attack vector. But there is a Google Cloud side to this Google Workspace weakness. And the Google Cloud side is on the left, as you can see, with the Orca logo. The Google Workspace is on the right with the Hunters logo. And we separate it like this because this is essentially what each of the organizations defend from or on. And this is a very great layout to understand how these products work together. And if you have both of them, the amount and the level of defense that you can reach. So what we've seen here is that if someone from the outside world can compromise a GCP compute VM via a remote code execution due to a vulnerable application running on this VM, he can essentially move laterally and compromise the assigned service account of this GCP compute VM. Now, just to explain a bit about service accounts and VM service accounts, service account in Google Cloud Platform is a bot identity. In GCP, you have two identities, humans and bots. Humans are users, and bots are service accounts. Now, when you have a VM in your environment and you want to assign an identity to this VM, so actions inside the VM could communicate with the cloud environment and other services in the same environment, you need to assign a service account to this VM. So this is a very basic principle in GCP. So what we're going to show in this demo is how an attacker from the outside can compromise a VM, then move laterally, compromise the service account. And this service account is going to be an editor role service account, which has a lot of permissions and is actually very equivalent to an administrator inside the environment. Then with this editor, we can move forward and implement DailyFriend, which Yonatan already described in basic level, so I'll not talk about it too much. But again, in a nutshell, you will be able to enumerate service accounts inside the environment, inside the GCP project, create a key to each one of them, and then try to use each one of the service accounts for JWT creation and then overall enumeration on OAuth scopes in order to try to see if you can nail a domain-wide delegation vulnerability. That's what we're going to show in this demo. So let's talk about the GCP part, the left side part. First of all, we decided to use editor in this presentation because in Orca, we ran some statistics and we figured out that inside our customers, within our customers, 70% of all attack paths, we have an attack paths feature service inside of Orca, which maps potential attack paths inside the environment due to due to gaps, security gaps inside the environment, and then just presents a graph from A to B to what a potential attacker can do. So within our customers, 70% of these attack paths are in GCP are leading to an editor. And the main reason is because people are using defaults. And when you launch a GCP compute VM and you just press next, 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 you're assigning something called compute service, the default compute engine service account. And this default compute engine service account, such a long name, is by default granted with the editor role. So this is the reason why we chose to present the demo with an editor role compromise. But it is important to remember that in order to implement Delifriend, you do not have to have editor permissions. You can have other permissions that grants you the ability to create keys for service accounts. This is the basic first thing that you need to carry this vulnerability and attack vector. So let's crack into the first part of the demo, which is this part. And as I share my screen, let's pray to the demo gods. Okay, so as you've seen in the diagram before, what I'm going to show you is a demo of compromising a GCP compute VM via a vulnerable application. And the application I used is a vulnerable Java application to Log4 Shell. And I have a basic sheet over here, so let's go through it, and then I'll run through the demo. So what I'm going to do here is I'm going to basically, I already have the Java application. So what I'm going to do is run the JNDI exploitation. And beforehand, I'm going to listen with an open source project called Rogue JNDI for the JNDI exploitation request. So essentially, this is going to listen for LDAP and HTTP. This is going to launch the exploitation that will access this LDAP server. And then the command you're going to see here is the command that's going to execute on the VM. This is a reverse shell command that's going to be targeting a netcat server that I'm going to be listening over here. And this netcat server will be exposed by an ngrok server that's going to tunnel the communication. So I hope everything clicks okay here, but basically, we're going to exploit the Java application and pull a reverse shell. That's what you're going to do. And then inside the application, inside the VM, because we move laterally and cross from the application side to the IAM side as an attackers, our objective is to move laterally and find more interesting stuff. We want to access the IMDS server, the instance metadata service, which, as the name suggests, contains metadata information about the VM. And one of the data points inside this server is the total of the assigned service account. So let's crack right into it. I have the ngrok server over here. I have the netcat server listening over here. And this is the Rogue JNDI that listens on LDAP and HTTP, which you're going to capture the exploitation request and then transfer a Java class that contains this command that will be triggered on my VM and carry a reverse shell. So already ran the ngrok and netcat and Rogue JNDI. Let's run the exploitation and pray again. And it looks good. So I'll just copy this command and let's go to full screen over here. So just to tap into an attacker's perspective, I'm on the VM right now, and I can run a few commands just as a basic reconnaissance, like hostname and who am I? Sorry. And I'm root, and I'm going to tell you already that I'm in a container because I'm not seeing any processes whatsoever that is relevant to a Linux machine. And if I also press and run mount, I can see I have a few clues that I'm inside a Docker container over here. Just as an interesting piece of information about the attack flow. And I'll cut the spoilers. We are inside a BusyBox. And BusyBox is a utilities package with utilities that you can see over here that runs on top of the system. And usually to access the IMDS server, I would be using CURL, but I cannot use CURL because I'm inside BusyBox and this utility doesn't exist. So I'll use wget, as you see over here, and it will work basically the same, but it will download the access token as a file to my local directory. So let's go to /tmp, just for the sake of organizing stuff. Let's see that the token I've downloaded before is not here, but it's here. So let's remove it here. Remove it first. And now let's run the wget command. And here we go. The token is here. And here is the access token. Now, I'll just copy it and to see it, but I'm going to send it to Yonatan right now so he can go through his part of the webinar, of the demo afterwards. But here we go. This is the access token. Now, let's talk quickly about what we can do with this access token. Because when an attacker gets permissions in form of credentials, it wants to know what to do in the environment. So if I take this access token and utilize it by accessing two different endpoints APIs provided by Google. The first one is token info, which grants me and provides me with this data, which is the unique identifier of the service account and the scope that it is using. Both fields are important. The scope helps me to understand what I can do inside the environment, and the unique identifier helps me to understand who is the service account. But this 21-digit number is not enough. So what we can do, we can use another access point, API access, which is this one. We will paste the unique identifier of the service account. And also, we need to add the access token over here. And it doesn't work. Demo guides after all. Let's give it another try. All right, here we go. So this is actually an equivalent to the command line, to the command gcloud IAM service account describe command. And what we did, me and Yonatan, we intercept this command so we could access it via HTTP like this. And what we can see over here is we have the compute engine default service account. And that's what we wanted to prove for the final part of this part of the demo, to understand what kind of permissions we have. And we have the editor. So we can now move to Yonatan's part. Yonatan, the stage is yours.
Cheers. Nice. Okay, so now we are moving to Delifriend. At this point, just to recap, Roi was able to compromise a GCP VM computing engine and using the IMDS, take the access token of the default service account that was attached to the VM. So we now, as an attacker, have the access token of the default service account of the VM that we compromised. Now I want to move on and see how we can use this access token in order to pivot to workspace and actually take over on the entire workspace. But before I explain about Delifriend, I want to delve into the concepts of Delifriend, which start with understanding what domain-wide delegation is, right? Because at the end, it is a legitimate feature that has a lot of productivity advantages to the team. So let's speak about it. So basically, DWD allows for identity object, external applications, or internal service accounts, this one in bold, to access data across workspace by impersonating to users via Google APIs. In simple words, it means that you can use GCP service account resource in order to impersonate to other users in the workspace domain. Now, one of the most important great features about domain-wide delegation that also make it really, really powerful and dangerous is that it allows to administrators and developers to access the user data without the need for the user consent. So you do not need for the user approval in order to execute those Google APIs on behalf of the user. So for example, an IT administrator that configure domain-wide delegation on a GCP service account resource do not need the approval of any user in order to access his data. If you think about it, it's pretty crazy because it is an unlimited access to all of the identities in the domain. It's also important to note, as you probably understood from the previous sentence, that it impacts the entire domain. So there is no restrictions here. When domain-wide delegation is configured, it is affect the entire domain, not just a single user. Now let's understand how the authentication works, right? Because at the end, Delifriend is abusing the way that the authentication is work. So it's important for us to understand how it works. So it will start with the initiator, which is the identity object, create and sign a JWT. JWT obviously composed from different claims, which we will see in the next slide. But what you should know about for now is that it will create the JWT and encrypt it with a private key of the service account resource. Afterwards, it will take this JWT object and will send it to Google servers. Google servers will validate it and will respond with a token. And this token will be able to use in Google APIs, for example, accessing the Gmail API, the Docs API, any API that is configured in the delegation. So this is really high level about authentication. Now, we know how OAuth 2.0 works, but let's discuss about the specific claims that Google are using when they are creating the JWT. What is the recipe of the JWT object that Google are creating for domain-wide delegation? So there are several of them, also some metadata attributes that we will see in the next slide. But the important ones are the target workspace user, which is the user that we are going to impersonate on, basically the one that we are conducting the API calls on in workspace, and the OAuth scope, which is the API scope that we can use as the identity object on that user. OAuth scope is basically a really important concept that Google developed that allows to restrict different API access to different delegations, right? For example, define that the scope will be only Gmail. So the identity object will be able to access only to the Gmail API. We will see it in my demo and also take a look at one of them, so it will be clear. Now, taking all of those together, it will be encrypted with the GCP service account key, and we will have a JWT with domain-wide delegation. This is the recipe for JWT with domain-wide delegation. Now let's take a look on the SDK source code that creating JWTs. And by the way, I will say that most of our research was starting with reviewing the source code and analyze the source code of the SDK packages of Google, and it helped us to understand how those works. So here we can see the method that are creating the JWTs, and I want us to take a look on the payload dict, which is in the center, and we can see there the claims that the JWT has. For example, the EXP, which is the token expiration date, by default, it is 1 hour. the ISS, which is another metadata attribute of the service account email. And we can also see the scope, which is the OAuth scope that the JWT created with. This telling Google to check if the delegation has an access to this scope. Now, at the bottom, we can see the subject. The subject is how Google clarify the workspace identity. I'm not sure why they describe this subject and not like email user or something like that. But this is how Google declare it, and this is the workspace user claim. So if you were curious on what is the method that's responsible for creating the JWT, this is it. And this is the recipe for creating JWTs. Now, up until now, we discussed about domain-wide delegation and about how good it is, maybe how dangerous it is, but not about DeliFriend. And I want to speak quickly about the root cause of DeliFriend. What is the problem here, the design issue here? So we can delve into the demo and understand how it works. So basically what happened is the domain delegation is defined. We found the domain delegation is defined and verified by the service account resource identification and not by a specific private key. And in other words, it means that delegations are attached to service account and not to keys in service accounts. We have the diagram here below that I want to explain for a minute. You can see that we have a GCP service account resource that attached to domain-wide delegation, and there are two keys. One of the keys is existing, for example, the key that the IT administrator created when he was created the delegation, and also a new key that us as an attacker or maybe someone else could create on the same GCP service account, which also have an access to Google APIs and have domain-wide delegation. Now, what it means basically is that instead of needing to secure a specific private key, like any reasonable authentication method, we now need to secure the entire GCP service account resource in GCP. If we put our hands on the GCP service account resource that have domain-wide delegation, we can control the domain-wide delegation and access the Google Workspace API. Now, all of this webinar is about understanding the risk with it. Like we have here Roi, which is extremely experienced GCP researcher, security researcher, and Orca, which this is literally what they are doing. Defending this one, the resource itself, is much more harder than securing one key. And this is exactly the root cause here. So basically, I will recap it. In case that I can compromise the GCP service account resource that has domain-wide delegation, I can create a new key for it, which will also have the domain-wide delegation and will give me the ability to access to Google Workspace APIs. Now, I will explain a bit about the concept of DeliFriend in this diagram, and then we will see a live demo how we can take the access token that Roi was extracted from the compute engine in GCP and move to Workspace. So basically, we have here the diagram of our attack path. By the way, for those that know DeliFriend before the webinar and saw the DeliFriend repo, you see that this is not the complete diagram of DeliFriend. There are more steps that DeliFriend is doing in order to enumerate all of the possible combinations. But me and Roi created a diagram that's relevant specifically on our case, which is compromising the default service account. So it will start with us creating a new key for each of the service accounts that exist in the project. Now, Roi said something important, and I'm just recapping it. The default service account has an editor permission by default on the entire project. And it means, because GCP is inheritance resource system, that we will have an editor permission on all of the service account resource. And in other words, it means that I can create a key on all of the service account in the project because I am the editor of the project. Simple as that. And afterwards, what we will do is to start to enumerate and fuzz all of the existing combinations, JWT combinations that we can manipulate in order to find one that have domain-wide delegation. It will be with iterating on each of the service account breaking down the JWT and creating one, first with the first OAuth scope, then moving to a relevant target subject user, requesting an access token via Google APIs, and validate this token. After we found a valid token, we can assume that there is domain-wide delegation on it, and we can use the key. Now, I know this can be overwhelmed and pretty complicated, but let's see the demo, and I'm sure that we will understand a bit more. As Nisimi said, it is all live, so let's pray to the POC God again, and let's do it. Okay, so I now in the PyCharm project of Delifriend, also in the terminal. You can use your terminal, obviously. I'm just using PyCharm because it's easier for me to go to the relevant code parts that I want to show during the presentation. I am inside the poetry of Delifriend, and we can get started. So Delifriend syntax is really simple, and it mostly automate. So what we will do is to basically run it and understand each of the steps that Delifriend does in order to do the exploitation. So I will just execute it. It's really simple. It's Python main PI C for the configuration file and V for verbose, because we want to debug things and see how things works. Obviously, if you are on a red team engagement and you do not want to see it, you do not have to. And before we run it, I want to go quickly over the config YAML file. So I have here the token that Nisimi gave me from his part. And the first parameter is basically the bearer access token. This is the access token that Delifriend will use in order to take the relevant permissions of the GCP IAM user and start doing its magic. So it is a mandatory attribute that you need to provide to Delifriend. Let's put the one that Roi provided to us. The second one is the workspace user email, which is basically, as we learned in the JWT 101, the attribute in the claim of the user that you want to impersonate to. Now, we added a nice module to Delifriend that does it automatically for you. It automatically enumerates the GCP projects and search for unique domains and take one user per domain, because we need only one user, right? Because domain-wide delegation is affect the entire domain. So you do not necessarily need to use it, but just know that you have an automatic option for that. Now let's run it and pray to the POC God. So we can see that the tool start to work, and it will start with enumerating the relevant project and service account and go on each service account and try to create a key for it. If you will go to the GCP enum class, we can see that we have the first method here of get the IAM email from the token. We basically taking the bearer token that we provided, and start to gather the IAM identity in order to check if this IAM exists on the get IAM policy of the target service account resources. So we can see here that we did it on three service account, and we were able to create a new key for each one of them. Why? Again, because we are the default service account. We can create keys on all of the service account, which is amazing. The next step would be to enumerate for a valid workspace subject, right? We learned about the need for a workspace subject, and Delifriend does it automatically for you. We can see here that it found one domain named Axon Corporation and a user that named Eli Ohana, which basically a valid user that the tool will use for the fuzzing and enumeration process of the JWTs. Now we're moving for the fun part. You can see here that we have total of 332 JWT combinations. Now, if you wonder how this actually count, you can go here to the OAuth scope enumerating module, and you can see here the method of total JWT combination, which basically take the number of scopes that we're providing with DeliFriend. We have here a predefined list that we created at a team that are basically all the OAuth scope that can be potentially abused. The number of service account keys that we were able to create, in our case, is 3, because there are 3 service accounts, and the number of target subjects. Target email, in our case, we have 1, because we have only 1 domain. So we have 332 combination, and we can see that the tool can start enumerate for all of those. Simply as that, try to find a combination and check it out. We have a valid access token with domain-wide delegation on the service account object for this service account and this scope. This is amazing. We can see the service account name Hunter SOC Platform, and it has this OAuth scope. If we go a bit down, we can see more of them. They are related to admin OAuth scope, which is really interesting. But all of them are for a read-only OAuth scope. So someone did a good job with defining the OAuth scope. Now we can see it is keep running. By the way, while it is keep running and we review the result, I will say that one of the mitigation steps that we recommended to Google is to limit the amount of JWT combinations that you can send to the target API, because it's not make any sense to allow such amount of fuzzing in a short time. So we hope that they will be able to address it as well. And look at that, very nice. We found another combination that found on a service account named delegated friend and with the scope of mailgoogle.com. Now, mailgoogle.com is really interesting OAuth scope. I want us to go to the documentation of the OAuth scope of Google. You can find it in the Google Identity documentation, and look on what this scope is. And we can basically see, as you imagine, it is the Gmail API. It is related to the Gmail API. But what's interesting here is that this is the master OAuth scope of the Gmail API. With this scope, you can access all of the methods in the Gmail API, while the others are separated. For example, specific methods, the ability to send an email. So this method can do all of the functions in the Gmail API, which are a lot, with this scope, which is pretty permissive. And now let's wait, it will finish, and we will see what we can do with this service account and see how we can actually do things in the workspace. By the way, I will say that the amount of time it will take is basically change between different organizations, right? Because if you have a lot of service account, it will take more time. Now the tool is finished, and you can see it finished with clearing the private keys. And we can see here that we have 2 private keys for those that we found with delegation. And now what I want us to do is to see what we can do with this delegation. Now, we know that the service account of delegated friend has Gmail API delegation. So I wrote here a nice fetcher, which is very simple. What it does basically is to list and enumerate all of the mails of a target user. We basically creating an object of the service account key, the scope, and the subject target email, and we are enumerating for all of the mails in the target inbox. So let's do it. It will be Python fetchers, which is the folder, OAuth scope in on Gmail, and we can see it gets 2 parameters, U and S. U is the target user. I just want to mess with Roi, so I will compromise his inbox. So let's do it. His name is Nisimi at axoncorporation.com, and I will take the U parameter of the delegated friend key, which is the key that can do it. And let's see how it works. And POC God, how is that? What's happening? Let's see. Let's do it on my user. Okay, I got it. If you can see, I put U instead of S in the flag. So let's do it like that. And you can see that I was able to pull out all of the emails that I have in the inbox. Simple as that. Obviously, the options are endless. Any API, any functions in Gmail API can be used. So just an example, and I can see that we are having issues with the time. So let's stop for now. And let's get back to the slide and run them really quick.
That was really good. I love all the subject lines for the emails as well. So if anyone didn't see those,
Yeah,
the
sharp guys code the message that me and Nisimi put in the inbox. Yep. So let's speak really quickly about the permission issue. At the end, every vulnerability in cloud and offensive technique in cloud is somehow related to permissions, right? The problem with the relationship between the permissions. So basically what happened is the super admin is the only rule that can create new domain-wide delegation. This is the only rule in Workspace that can do it. By the way, it also can't be done programmatically, only via the UI, because Google probably understood how sensitive this feature is. We, by the way, doing the research, try to find a lot of ways to do it. With undocumented and documented ways, we couldn't find it. So Google did really pretty good job with defining it. And we also know that the GCP editor role can use the service account key creates permission in order to create new keys on all of the service accounts in the project. And in other words, it means that we can potentially abuse domain-wide delegation. Now, it's very important to clarify that super admin is not, it can be equal to default service account or GCP editor role by any case. They are totally on different levels. It's like to compare if we are speaking about on-premises, local admin, and domain admin. Super admin is the higher privileges in Workspace, and we can't take such permissions default service account and give the ability to compromise it and leaking into the to the Workspace. So now that we spoke about it, let's speak quickly about best practices. So the first one would be to create service account with domain-wide delegation on a separated projects. Please know that when you're creating service account with domain-wide delegation on a project with potential initial access vectors, as Roi mentioned in his demo, you are putting a lot of risk here, and you can potentially lead to compromising the domain-wide delegation feature. So if possible, just separate it to separate project with no without the ability to have an initial access point. Also, make sure that you limit the OAuth scope as much as possible. Use simply the OAuth scope that you need, nothing more than that. Just the methods and the functions that the applications or the IT administrator is need to operate. The third thing is to implement detection engineering and threat hunting practices. Basically, we published DeliFriend around 2 months ago, and we already start to hear about incidents that started to give threat actors the idea of compromising domain-wide delegations. As Nisimi said, SOE said, editor role, compromising the editor role is very prevalent. So now attackers know how they can use it in order to move to Workspace. So it's really recommend to develop detection engineering and threat hunting practices. In the Hunters blog, we published a lot of them, a lot of threat hunting queries and detection engineering queries. Obviously, for Hunters customers, it developed out of the box, so you can get it out of the box. But in case you're using other platforms, feel free to just check out our blog and just copy the logic and use it. And the last one is continuously looking for posture gaps and close them. We also publish threat hunting queries for posture as well. So check them as well. Check that you do not have domain-wide delegation service accounts that are not in use. You can delete them. And yeah, I think that's all for the best practices.
Oh, wow. Thanks, Yonatan. That was incredible.
Great.
So just to cover up the left part of the diagram that you've seen before, the Google Cloud Platform part. So first and foremost, avoid the defaults. If you just create services and keep the defaults on, you are potentially carrying security vulnerabilities and security weaknesses. So create custom service accounts and assign these custom service accounts to your workloads. That's the best first thing you can do. Second thing, very common, least privilege. Follow the principle of least privilege, which means when you create a custom service account, apply granular permission control and inhibit unnecessary API scopes or API permissions, which means when you create a service account, make sure it can only do what it's supposed to do and anything beyond that. Third point, do not skip patch procedures, because if you skip them, then you are still vulnerable to log4shell. And this is very common. We are looking at plenty of customers inside of Orca, and we can still see log4shell vulnerabilities. So make sure you follow, update, and patch, and you maintain these procedures, and also follow security advisories for softwares that you are using. If you're using some product and there is a new security advisory, a new patch, a new update, make sure you are noticed and follow the principles as they are written. And 4 point, if you can, then implement a vulnerability management solution. We do have one inside of Orca, and it works amazingly well. And if you have a management for vulnerabilities, you can solve the issue right when it starts with the initial access. So that's it for this side.
Well, that was fantastic. It was really good. Well done, both of you. I was really enjoyed the whole thing, and all the way through, it went very smoothly. Congratulations! I was really pleased. The time we've ran on, and so I really appreciate everybody who's hung on to this. The recording will be available. We'll of course share that out. We don't really have time to go through a lot of questions. I do have one that's seen coming in that I think's relevant, but they're all relevant. But one in particular would be, you've spoken to Google. Google have been quite clear. What would your recommendations be? I know that came up during the talk. There was an idea, but what would you do if you were Google? And of course, Google have already looking at things. We're not Google, but what would you suggest?
Yeah, it's a really good question. We also published some of our recommendations in the blog, but basically one of our biggest recommendation was to switch from having the definition of delegation on the entire service account resource and switch it to a specific private key. So instead of securing the entire resource, securing a specific private key. I will say that we understand that it is a trade-off, and maybe organization use dynamically key creations, although we couldn't find any at our customer base any anything like that. But we also suggested them to give the option of an optional requirement of providing a key. So if the organization want to provide it, to define it on a specific private key, they will be able to do it, and it will solve the issue for both sides. So this is one of the biggest recommendation that we provided to Google, and we know that they are evaluating the possibilities, and we are on an open ticket with them. So hopefully we will have a solution soon.
That's fantastic. Once again, I really do take my hat off to both of you. Really good, very entertaining. I really enjoyed it. I think there's certainly something that we'll have on demand for everybody. I mentioned at the beginning, we will get these slides out as PDF. People will be able to download them and have a look at them. I do encourage everyone, of course, to reach out to Orca, but also reaching out to hunters. I think that this has showcased the level of expertise that we've got in both organizations, and certainly the passion we have for our customers and the work that we put in for that. So once again, to both of you, thank you very much. And to everybody here on the call, thank you for attending. And I hope you'll rewatch the recording and get a lot out of it. Thank you.
Cheers, guys. Thank you.
Thank you, guys. Bye-bye.